Okay, we'll do that for this. Okay, today we're working on factoring. The quadratic form of ax squared plus bx plus c. Now, in these methods, this is when a is a number other than 1. Okay? So this will be a little different today. So our first example, we're going to factor the form of 6x squared plus 17x plus 12. Now we're going to do the method we had learned the other day. Sorry, this is not 5.4, this is 5.5.
Jeez, making me go back.
And I'm also going to show you that decomposition way. So we're going to learn 2 different ways to do this. Now, this is very similar to what we did the day before. First, we need to recognize this is our A term, our B term, and our C term. If this question was possibly written out of order, so I'm going to write it over here. Let's say we had 17x plus 6x squared plus 12. You would have to rearrange it so that the variable with the highest exponent is the first term, variable with the next highest exponent is the next term, and so on down to the constant being the last term. Make sure they're in order when you go to factor like this. They're going to get some questions where they are out of order. You will not be able to factor this way when they're out of order. So, first thing we do is find the factors of our A term. Our A term is 6, so our factors are 1 and 6, 2 and 3. Our C term is 12. Factors of 12 are 1 and 12, 2 and 6, and 3 and 4. If you guys remember, we need to find the products of the numbers, and they need to add to our positive 17. Once we find our numbers, we're going to be putting them into our 2 brackets, which will be our factored 4. Just as, a side note, I need to look for the greatest common factor first, and I quickly looked through this. 17 is a prime number, so there was no greatest common factor to pull out. Always look for the greatest common factor first. So now that I've set this up, we have our columns. We're going to go through the columns to figure out pairs of numbers that multiply and add up to positive 17. So we're going to start with 1 and 6. 1 times 1 and 6 times 12 is going to give us 72 and 1. Is there any combination of 72 and 1 that makes 17? No. Now we're going to go across. It's very important that you guys realize we don't just go straight across, but we also cross the numbers. I'm going to use 1 times 12 and 6 times 1. That will give us 6 and 12. Any combination of that work? No. Okay? So we know this first column won't work for 6 and 1, but we don't completely cross it out because if 6 and 1 don't work, we have to retry it with 2 and 3. Now we do 1 times 2 and 6 times 6. That's 2 and 36. Anything? No. 1 times 6 and 6 times 2. That's going to be 12 and 6. Does that work? No. And finally, 1 times 3 and 6 times 4. 3 and 24. No. 4 times 1, 6 times 3. 18 and 4. No. Even if they're negative, doesn't work. So what I've discovered is that this set here, anything times 6 and 1 did not work. Now, we're only left with this column. So we can assume they're going to be our first terms, but I'm just going to double check. I'm going to go through it all before I put them in as our first terms, okay? 2 times 1 and 3 times 12 gives us 2 and 36. No. 2 and 12, 3 and 1. That gives us 3 and 24. No. So, now since I'm down to my last set of first terms, and I know 12 and 1 didn't work, I can cross 12 and 1 out. I've tried it with both sets of first terms. It didn't work. 2 times 2, 6 times 3 gives us 4 and 18. 2 times 6, 3 times 2, 12 and 6. No. This second set didn't work. We're only down to these two. It's most likely these are going to be the two that work. Then we got to figure something else out. 2 times 3 and 3 times 4 gives us 6 and 12. 2 times 4 and 3 times 3 gives us 9 and 8. Anything of those work? Yes, they do. Now, I'm drawing this in permanent now. 3 times 3 and 2 times 4. Because remember, it's very important I know which numbers I multiplied by each other. I ended up with 8 and 9. And as long as they're both positive, they'll add up to positive 17. So I know both of my second terms need to be positive. And that works out because positive 3 times positive 4 equals positive 12. I'm going to write my first terms in, which was my 2 and my 3. So I have 2x in one bracket and 3x in the other bracket. Now my second terms, this is where it gets a little tricky. I multiplied 2 times positive 4. So that means 2x and positive 4 have to go in opposite brackets. Okay? It's very important they're in opposite brackets, otherwise we've actually factored this incorrectly. I also multiplied 3 times positive 3. So that means my 3x and my plus 3 have to go in opposite brackets. So I'm just going to rewrite this. Our final answer is 2x plus 3 times 3x plus 4. Next method we're going to learn is decomposition. Now this is very similar to the shortcut I taught you when A was 1. What we're looking for through decomposition, you know what? I'm going to move the bottom part here just a little. For decomposition, we're looking for two numbers that add to B, and the same two numbers need to multiply to A times C. Okay? Before it was only C, if you guys remember. We'll write the C in green. If you guys remember in that shortcut method before, that's when we had two numbers that added to B and multiplied to C. This time they need to multiply to A times C. So, we're going to show you what that looks like with our next two numbers here, or our next equation. That means we're looking for two numbers that add to 17, and the same two numbers need to multiply to 6 times 12, which is what? 72. So we need two numbers that add to 17 and multiply to 72. So what I need to start doing now is I need to start writing out the factors of 72. Okay? And there are a lot of them, so I'm going to write them underneath here. We have 1n 72. We have 2n 36. 3 24. Good. Oh, you're good at this. 4 and 18. Thank you. 8. There we go. So, we've now written out all of the factors of 72. Now we need to find pairs that are going to add up to 17. So, will 1 and 72 work? No, they don't. 2 and 36? No. No, no, no. What are we looking for? 8 and 9. Now, in this part, it happened to be easy, but sometimes you'll get very large numbers here where you're going to have a very large set of factors, plus you have to try them when they're negative and positive, so it gets a little more confusing. This was a bit of an easier example. So we know that the two numbers we needed are positive 8 and positive 9. Okay? Now, this is where it gets a little tricky for decomposition. We have 6x squared plus...
All right, good afternoon, the field.
Okay, again with decomposition, We're rewriting this out. Now, this is what's very important. The two numbers we decided to use were 8 and 9. So what we're actually going to do is we're going to be splitting 17x into 6x squared plus 9x plus 8x. So the two numbers that we found that added to 17 and multiplied to 72, we input them into the equation, and our middle term, or our b term, is split into those. So I'm going to actually rewrite them in blue, just so you guys color code this a little. The two numbers we found, 9 and 8, were the two that are going to work. Now that I've split them, I'm going to do factoring by grouping. Okay? So I have two groups. We have 8x and 12, and 6x squared and 9. I find the common factor to the first set. A common factor to the first set will be 3x, and we'll be left with 2x plus 3. And then I find a common factor to the second bracket. So this was the first. Common factor to the second bracket, we're looking at 4. So we'll have 2x plus 3. Now that I've taken common factors out, if you guys notice, both of the brackets are the same. I factor the brackets out, 2x plus 3. And in the other bracket, I put whatever is left over, which is our 3x plus 4. So I have 3x plus 4. So just as a comparison, those are the two methods we've just done. The one on the right was decomposition. The one on the left we call Mr. Tanani's method, okay? Okay. To start off factoring this question, like all questions, we need to look for the greatest common factor. If I quickly take a look, the greatest common factor to all three of these terms is the number 2. So, when I factor 2 out, it goes to the outside of the brackets. We've taken out the 2. And when we divide the terms, we're left with 8x squared plus 13x minus 6. Now that I've taken that out, I need to factor the brackets. And we're going to use two methods to factor the bracket. First way, we'll do Tonani's method, then we'll do decomposition again. In the Tonani method, we find the factors of the first term are a, which are 1 and 8, 2 and 4. And the factors of our second term, which are 1 and 6, 2 and 3. We know that their products need to add up to our b, which is 13. So when I quickly look, 1 times 1, 8 times 6, that's not going to work. 1 times 6 and 8 times 1 is going to give us 8 and 6. That won't work. 1 and 2, 8 and 3 gives us 24 and 2. That won't work. 1 and 3 and 8 and 2 is going to give us 16 and 3. That will work. A combination of 16 and 3, if 3 is negative, when we add them together, we will get positive 13. So, I'm going to be using 8 and 1 and 2 and 3. Now remember, I multiplied the 8 times 2 to get 16, and 1 times 3 to get 3. Our 3 needed to be negative, so that means this term here, in the brackets, or in our column, sorry, is going to be negative. And just to double check, positive 2 times negative 3 is negative 6. Remember, it has to multiply to that. Now when we put it in our brackets, I cannot forget my common factor that I've had on the outside. So I have 2, and then inside of our brackets, our first terms are going to be 8x and x. Because I multiplied 1 by negative 3, the 1x and the negative 3 have to go in opposite brackets, which means my 8 and positive 2. That's a funny looking 2. need to go in opposite brackets. Okay? Quickly underneath, I'm going to show you through decomposition the exact same question. Let's assume we've already taken out our common factor of 2, and we have 8x squared plus 13x minus 6. Now remember, we need two terms that are going to add to 13, and they're going to multiply to 8 times negative 6, which is, anyone? Negative 48. Okay? So our terms for 48, instead of writing out our two options, negative 1 and positive 48, and negative 48 and positive 1, I'm just going to set them up as a pair, and we're going to have to think through it. So we have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Okay? We know those are going to work. I need to look through these. Because this is negative 48, I know one of these terms is going to have to be a negative. Okay? So I'm going to think through it. When I add these together, are any of them ever going to equal positive 13? We know from before that our numbers are going to be 3 and 16. And if the 3 is negative, we know we can get to positive 13. So negative 3 and positive 16 will be our terms. So we're going to rewrite the question. 2 times 8x squared plus 13x minus 6. Through decomposition, we're using negative 3 and positive 16. So I'm going to split the question up. I'm going to get 2, 8x squared, negative 3x, positive 16x, minus 6. Now, I could have put positive 16 first and negative 3 second. We're still going to get the right answer, okay? It's just going to factor a little different. It'll still work. Now, in the brackets, again, remember, I need to factor by grouping. So I'm going to find the common factor for 8x squared and 3x, which is, anyone know? Is there a common factor? No? X? X will work. So we take x out and we're left with 8x minus 3. Okay? Then I find the common factor between 16 and 6. Anyone know? 2. I take 2 out and I'm left with 8x minus 3. Again, our brackets, if you notice, are the same. So I'm going to factor the brackets out. I'm left with 2 times 8x minus 3. And in our other brackets, we take the other terms that are left over, which are x and positive 2. And there is our factor form. So we've done it through decomposition and the other method.